Please wait a while. Okay, enough. I will reshare my screen again. Here. Do you see the screen?
Still loading, sir. Now we can.
Oh yeah. Okay. Here. What is the importance of understanding black body radiation and photoelectric effect? So black body radiations we learn if previously we study, Earth and space science. Have you studied the sun and the star? Yeah, the star, or understanding the sun. It's very hard, to measure directly the temperature of the sun. Yeah, which thermometer you need to investigate the temperature of the sun. But by understanding the radiation from the sun, we can investigate how hot the sun, yeah, the star, also the distance of the star, yeah, from us. And also we can understand the natures of the universe, yeah, how the universe created, yeah, at the first time. And afterward, how the star and becoming what spread the dust, and the dust becoming a planet. Yeah. And also photoelectric effect. Yeah, it's interaction of metal to electromagnetic wave. So what is photoelectric effect? Photoelectric effect is the reaction of the material to electromagnetic wave. Yeah. Okay. So previously, in the quantum mechanics, yeah, have revolutionized, yeah, as firstly explained by Max Planck. Yeah, Max Planck. Many other physicists, yeah, were involved in other subsequent of the development, especially a theory regarding what radiations, yeah, wind, and afterward followed by wind. What make an object having a temperatures, Mufti?
Because they receive the energy.
And then what happened afterward when it received the energy?
I don't know.
Diki or Rizky, would you please support what make an object having a thermal radiations?
Maybe because the energy is convert. So, for example, when the object move, and it can convert energy gerak to heat energy, maybe, sir?
Yeah. So what is the meaning of heat? Thermal energy. So what happened when an object receive an energy from the photon? It will vibrate. Yeah, vibrate. Yeah, the vibrations creating electronic excitations. Yeah, and also the thermal energy. Yeah. So why it has a thermal? Because the atom vibrates. Yeah, it collides each other and then propagate the energy. Yeah, from one point to another point. Yeah. So if an object, yeah, getting an energy, yeah, it vibrate. A vibrations, the stronger the vibrations, the greater the temperatures. Yeah. So once an object of a material receive an energy, yeah, so the material will vibrate. Yeah, the stronger the vibrations, so that the greater the temperatures. And what happened afterward? If an object vibrate quickly, yeah, in the high temperatures, it will emit also the radiations. Yeah. Okay. What is and also Allah also say in the Quran, yeah, as we know, the moon reflect the light from the sun, and sun, okay, produce or radiate the light because of its vibrations resulted from nuclear reaction inside, right? nuclear reactions. Fusion or fission? Diki?
Nuclear fusion, maybe, sir. Fusion.
Okay, fusions, hydrogen to hydrogen becoming helium. Yeah, but afterward, after the fusions and also the mass of the sun will reduce. Yeah, we have a defect mass. A mass defect of sun, it will be converted into radiation energy. Yeah. So when the sun radiate an energy, what happened to the sun mass afterward? Mass of the sun will decrease, and decrease. What happened if a mass of the sun decrease? It will affect to the gravitation of the sun. Yeah. If a sun gravitations reduce, what happened to an object? Yeah, surrounding the sun.
It will scatter away. The velocity or the acceleration of the planet is gonna be more higher than the gravitational force, and then the planet is gonna be go away from the sun.
Okay, so as consequence, it will change a period of the sun. It will change the period of Earth orbiting the sun. And sometime, I believe that sun will rise from the west side before kiamat. Yeah. So if sun release an energy in a high value, and afterward it will change the gravity. Changing a gravity will affect, yeah, it follow the Kepler law. It will affect also a distance of the Earth to the sun, and also sometime there will be happening to the Earth itself. Sometime we have also kiamat. So kiamat will be true. It will happen based on the scientific inventions. Okay, so that's also another consequence. Yeah. Okay, so black body itself, it radiates, yeah, because of thermal radiations. Yeah, but temperatures, it does not depend on the material. It's only depend on temperatures. This is the uniqueness of radiations. Yeah, the radiation of the black body, it only depend on the temperatures. For example, here we hit the metal. When we hit the metal into 1,000 degrees Celsius, what happened? Will the metal glow? The light? Have you ever seen when you burn a material, what will happen to the material? Diki or Rizky or Arni?
For 100 degrees Celsius, sir?
Yeah, in 1,000 degrees Celsius.
Yeah, it will glow some light.
Glow.
From the
Would you please describe the color of the metal when it glow, when we hit it above 1,000 degrees Celsius? Have you ever seen?
It's from yellow to red, I guess.
Yes, it will be showing red. And what happens if we increase the temperatures of the metal when we hit it above the stove? Firstly, initially the color will be red, but afterward, in the higher temperatures, from the red will become orange, and it will become yellow, and it will become blue, and it will become violet. Which one is the greatest temperatures?
Violet one, I think.
Huh?
In violet one, the greatest.
Violet. Okay, violet. Yeah. Do you have a gas stove in your house? Which one convert into the fuel stove? You know, in the gas stove, the color of the fire is blue, right? Yeah. In the glow in the high temperatures compared to the what? Compared to the red fire, right? So blue fire will be what? Radiate higher energy. Yeah, compared to the red fire, right? Yeah, that's a fact. It's a fact of the radiations. Yeah. So black body radiation only depend on the temperatures, not depend on material type. Yeah. Okay. Okay. So there's a black body radiations. Yeah. And also we have a material which completely receive a heat, what we call it? Is there any material in the world which receive all the radiations? Is there any material? What happens if people receive radiations? For example, black hole. Have you ever heard black hole? Maybe I have a black hole video. Yeah, this is the condition when the material receive whole energy. So, okay.
Black holes are among the most fascinating objects in our universe, and also the most mysterious. A black hole is a region in space where the force of gravity is so strong, not even light, the fastest known entity in our universe, can escape. The boundary of a black hole is called the event horizon, a point of no return, beyond which we truly cannot see. Once something crosses the event horizon, it collapses into the black hole's singularity, an infinitely small, infinitely dense point where space, time, and the laws of physics no longer apply. Scientists have theorized several different types of black holes, with stellar and supermassive black holes being the most common. Stellar black holes form when massive stars die and collapse. They're roughly 10 to 20 times the mass of our sun and scattered throughout the universe. There could be millions of these stellar black holes in the Milky Way alone. Supermassive black holes are giants by comparison, measuring millions, even billions of times more massive than our sun. Scientists can only guess how they form, but we do know they exist at the center of just about every large galaxy, including our own. Sagittarius A, the supermassive black hole at the center of the Milky Way, has a mass of roughly 4 million suns and has a diameter about the distance between the Earth and our sun. Because black holes are invisible, the only way for scientists to detect and study them is to observe their effect on nearby matter. This includes accretion disks, a disk of particles that form when gases and dust fall toward a black hole, and quasars, jets of particles that blast out of supermassive black holes. Black holes remained largely unknown until the 20th century. In 1916, using Einstein's general theory of relativity, a German physicist named Karl Schwarzschild calculated that any mass could become a black hole if it were compressed tightly enough. But it wasn't until 1971 when theory became reality. Astronomers studying the constellation Cygnus discovered the first black hole. An untold number of black holes are scattered throughout the universe, constantly warping space and time, altering entire galaxies, and endlessly inspiring both scientists and our collective imagination.
Yeah, it was a theory of the black hole previously, but now the evidence of the black hole was discovered by scientists in 1971. Yeah, you can imagine how Einstein predict a black hole while he didn't observe the black hole in that era, right? They predict it based on their sense, yeah, and their understanding of the matter, yeah. And afterward here, why we have to understand the quantity of black body radiations, yeah, instead of here photoelectric effect. Maybe this video will be so meaningful for you.
He knows a lot about the science stuff. Professor Dave explains.
We know that the classical physics of Newton and pals reigned supreme for a few centuries. So what were the events that finally exposed its limitations? What was the first thing that suggested there was more to the universe than we had previously thought? This seismic shift was initiated in 1901 when Max Planck solved something called the ultraviolet catastrophe. The problem went like this. Certain objects are called black bodies because they emit electromagnetic radiation of all wavelengths. The sun is an example of such an object, and we can take a look at the distribution of the wavelengths of light that we receive from the sun. Most of it is in the visible spectrum, which is why our eyesight evolved to pick up this kind of light. But we also receive light on either side in the UV portion as well as infrared and beyond. A hot piece of metal will also do this, and this was the way we studied black bodies at the time, noting that the distribution depends not at all on the material, but only on temperature, with the particular wavelength that is emitted with maximum intensity shifting left as temperature increases. This maximum will move into the visible spectrum at around 4,000 Kelvin and above. This is why very hot objects appear to glow, like a hot oven, light bulb filament, or the sun and other stars, because objects at these temperatures emit a lot of visible light, as opposed to something like the human body, which at around 310 Kelvin emits essentially no visible light, which is why we can't see each other in the dark. The problem with the black body spectrum was that classical electromagnetism could not account for it. Mathematical models attempting to produce these distributions were able to fit the data for the longer wavelengths, but they did not predict that the intensity would dip down to the left for the UV portion of the spectrum, as experimental data illustrated. Instead, the math predicted that the intensity would continue to increase as the wavelength decreased, and become infinitely large as the wavelength approached zero. Of course, we know that this can't be true, otherwise every time you use the oven, you would get blasted with UV radiation. This contradiction was dubbed somewhat dramatically the ultraviolet catastrophe. In science, if a theory does not accurately align with observations of reality, it must be revised. And so, we realized that classical electromagnetism, as powerful as it is, must have some kind of limitations in its ability to describe light and energy. As we said, Max Planck solved this problem, and he did so by introducing a concept called quantization. We know from classical physics that heat is just the transfer of kinetic energy from one place to another. In the case of a piece of solid hot metal, that kinetic energy takes the form of atomic vibrations, or oscillations. These vibrations are what generate the light we see in the black body spectrum. Planck proposed that the vibrational energies of these atoms, and by extension, the energies of the electromagnetic waves emitted by these atoms, must be quantized, meaning that rather than being able to take on any value from a continuous series, they can only possess specific, discrete values from a set of accepted values. In this way, he developed this expression for black body radiation, where energy is equal to n, which can be any integer, times h, a term we call Planck's constant, equal to 6.626 times 10 to the negative 34 joules seconds, times f, the frequency of radiation. The n value is what results in quantization, as it can only be an integer, and not any fraction or decimal in between, meaning that the resulting energies will also comprise a set of allowed values, with anything in between being forbidden. This application of quantization and the accompanying Planck's constant were developed in ad hoc manner, meaning that they were simply proposed for practical purposes, but they allowed for the accurate prediction of the true distribution of black body radiation at all wavelengths, which meant that this constant was more than a mathematical fluke, but a clue as to the fundamental nature of reality. And the fact that Planck's constant is so incredibly small explains why the notion of quantization of energy had not cropped up before, because it shows that energy is quantized on such an incredibly small scale that the gradations between the allowed values are utterly minuscule, so as to appear non-existent to any measuring apparatus. Energy appears to be continuous to macroscopic beings, such as humans, but on the fundamental level, it is indeed quantized, even though this conclusion was so strange that most scientists of the time, including Planck, couldn't believe that it had actual concrete physical meaning. This was the first time that quantization had solved such a big problem in physics, but it wouldn't be the last. It was the first in a series of developments that would utterly transform the field of physics, and by extension, our perception of reality. While Planck's work solved one problem, it created another. Why is there quantization of energy? This marked the beginning of the quantum revolution. So let's continue and see what happened next. Thanks for watching, guys. Subscribe to my channel for more tutorials.
Okay, so what can you conclude after viewing the material? Agnia.
So from what I can conclude from the video is that black body radiation is when an object emits a light when inside of them the atoms are vibrating because they receive the heat. And actually this before the quantum revolution, there is a phenomenon called ultraviolet catastrophe, meaning that
Catastrophe. Yeah. Ultraviolet.
Meaning that the longer the wavelength and the shorter the wavelength, that it will result in higher energy. But it wasn't true because there wasn't any of that happened back then. And then after Max Planck discovered the concept of quantization, for every wavelength, now it can be found the energy for each wavelength. I think that's from what I've concluded. It's because of the quantization.
Yeah. So maybe this catastrophe ultraviolet was found when, increase the temperatures, it will increase the energy. Yeah. Increase the energy in the lower wavelength. Yeah. Yeah. So when it approaches unlimited, so the wavelength approaches zero. So the consequence in the classical theory, they will found that energy will be unlimited. But in fact, as we have found it from the sun and also from the star, the ultraviolet is limited. So in fact, it was proposed by Max Planck, regarding the revolutions of quantum. So Max Planck et al., and also supported by the Einstein, have found that the energy must be quantized. Quantized. When it quantized, we have the energy will be E equal to NH, Planck constant times frequency. So it fit with the natural observation as found by astronomer. Astronomer find it from the star observation, have found that we can predict it to understand the size of the star, the distance of the star. Do you ever remember? In Earth and space science. Finally, we can predict it, the nature of the universe. Okay, so we will show another presentation material. Is there any question before we continue to the presentations? Okay, so we will continue here. So how about the power? Radiations. So the radiation of P, equal to here tau, Stefan Boltzmann, constant, A, area, E, this is emissivity, the maximum is 1 if it's completely black, and also temperatures, power 4. And also here, as firstly found by Wien's theory, that the maximum peak of wavelength of the radiations times T equal to 2.898 times 10 to the power of -3. What is the meaning of M here? Not millikelvin. This is meter times Kelvin, So M here meter and K Kelvin. Okay, intensity of the black body radiation of summary. Okay, and this Rayleigh law. This is the classical theory have found that the intensity of the radiations will be the same of temperature over lambda times 4. So, but at the long wavelength, it mates, but at the short wavelength, this one, yeah, it doesn't match, yeah, from the previous Rayleigh-Yin law, yeah, but finally it found by Einstein or Planck, proposing the energy equal to H, yeah, C over lambda, yeah, okay. And afterward found by Max Planck, yeah, found the quantizations of the energy. He awarded also Nobel Prize, yeah, of quantized nature of energy. Yeah, Planck proposed these equations. Yeah, previously the equation like this, yeah, Rayleigh-Yin law, based on the observations firstly found by Wiens, yeah, because Wiens have found only the peak of wavelength, only a peak of wavelength of the star, yeah, a peak of wavelength. For example, a temperature of the sun is 6,000, right? And also we have found it based on the observation of the color of sun. Color of sun is what? Yellow, right? So as the consequence, we know a peak temperatures of the sun on the surface of the sun have found approach 6,000 degrees Celsius. And afterward followed by Rayleigh-Yin and also follow, and afterward Max Planck with here revolutionize, yeah, the energy, yeah. So this one by proposing this formula, yeah, based on the frequency of the oscillations, yeah. So afterward the energy must be discrete, yeah. Here this is the assumptions, yeah. Assumption will happen during the excitation of the photon from the material. Okay, but afterward, all the energy having a stage. Yeah, this stage 1, 2, 3, 4. Okay, so here is the Planck, and as the consequence of Max Planck, okay, Einstein firstly proposed the photoelectric effect. Yeah, so the first founder of solar cell is Einstein by photoelectric effect. Yeah. Okay. So what photoelectric effect happened here? Not all of the light, yeah, not all of the light absorptions could result, yeah, electric current. Yeah, it's only a specific of wavelength received by a material, yeah, will make electrical current. So this is proof the evidence of the energy must be quantized. Yeah, when the energy quantized, okay, the evidence of only a specific light, yeah, in specific frequency, in the minimum frequency, so that there is electronic excitation in the material. So we know we have a minimum voltage of the material, yeah, okay, minimum voltage to stop a current. For example, here I have two frequency, for example, two wavelength, yeah, to make it easier. 200 nanometer, okay, 400 nanometer, and then 600 nanometer. Yeah, when we apply 600 nanometer into a solar cell, yeah, there is no electricity, yeah, there is no current. But when we apply, yeah, okay, radiate 400 nanometer, okay, expose it through the solar cell, it will result electricity, yeah, okay, electric current and also potential difference. Okay, but we want to stop, okay, the current. How to make a current stop? We need a resistor, yeah. We apply a resistance and increase the potential difference, yeah. At some time we have a potential difference to stop yeah, electricity. So this stopping potential, we call it as finally we know band gap. Finally we know it as band gap. Yeah, working potential. Okay. So what is the consequence of understanding stopping potential? Any material has a specific band gap. Yeah. When we have a photon greater than its band gap, it can produce electricity. It can produce electronic excitations. But if we have photon lower than band gap of the material, yeah, this energy cannot be received by material to excite the electron, yeah, from what we call it Valencian band. Yeah, Valencian band. Yeah, have you ever studied before last week? Yeah, last week. Yeah. So in the classical prediction, they say that if we increase the intensity of the light, it will increase the energy. But in fact, if we provide, yeah, a light with a lower energy, yeah, although we increase its intensity, it cannot produce an electricity, yeah, to the solar cell. So to make a solar cell having an electricity, we need a minimum wavelength so that this wavelength will be received by solar cell to create electricity. So this is the consequence of quantum energy. Yeah. Okay. Here, okay, kinetic energy. Yeah, HF minus working potential. Working potential. Okay. So specific material having a different working functions. This, yeah, sodium, aluminum, ferrite, copper, zinc, yeah, okay, platinum, and so on. So photon model explanation of photoelectric effects. Yeah. So K refer to kinetic energy is independent of light intensity. It's only dependent of material. Yeah, any material have a specific kinetic energy maximum. Okay, depend on the light frequency and work functions. Yeah, so to make a solar cell having electricity, we need a specific frequency. We need a specific material. Yeah, work function refer to specific material. Light frequency depend on specific light. Yeah, not intensity, but its frequency. What happens, sir, if we fulfill the specific frequency and we increase the intensity? It will increase also the current because we increase the number of photon emitted from the light. Here, this is the experiment proven by Einstein. Yeah, cut-off frequency. Yeah, and afterward, here the Compton effect. Okay, this the phenomena of scattering, scattering, and now we have neon, yeah, LED lamp, and so on. Compton effect. Yeah, de Broglie. De Broglie found that an electron, yeah, does not orbit in the specific positions. This is the consequence. Yeah. So finally, also by Max Planck have found the quantizations of chemistry. Afterward, it also affect to the chemistry. In chemistry, there is an orbital, yeah, suborbital, yeah, SPDF afterward. And also people now using electron microscope, yeah. Okay, so finally is a quantum, and we now also diffractions. In last week experiment we have done, yeah, to investigate the material. This is uncertainty principle. Heisenberg. Wow, that's enough. Okay, so okay. So any question, please?
I have a question, sir,
Okay, Diki, please.
but it's kind of crazy, sir.
Okay, how crazy your
So
question?
yes, so the black hole is made because there is a material that's so dense, so it has a great gravitational force that exerts. So is it possible that humans in the future can make a black hole because they have the technology to dance any materials that can be having that kind of gravitational force and become a black hole? But if it's happening, then the Earth is gonna be sucked into the black hole itself. How it's supposed to be, sir?
Yeah. So the gravity also depend on mass, Diki. So if the people or we want to interact our planet to our artificial black hole, we have to over a black hole having a greater mass than the sun. It's impossible, right? As we know, our Earth it's only 1/1,800 times. So it's impossible to people to create a black hole mimic a real black hole in the nature. But the people only, for example, praise a material. So I believe before inventing black hole, yeah, artificial black hole for a specific purpose, the people could realize uh, what artificial diamond. Yeah, as we know, people could make a diamond, yeah, from graphite, right? So you just burn a wood, and afterward, wood was compressed, yeah, in a specific pressure and specific temperatures. So the graphite will become diamond. Yeah, it has been realized today. Chinese scientists or American scientists, yeah, have pressed the material into high density, and afterwards, the what material structures crystalline, becoming diamond. Wow, it's glow. I believe also to black hole could be realized sometime. Yeah, as long as we
Then,
have an
sir,
equipment.
how about if it's impossible to make that kind of black hole, can we make a object that has its own gravitational? So it's gonna be deflect the gravitational force even from the Earth itself. So we can kind of float with that kind of object.
So making like here fusion reactions. Now people have utilized fission reaction, right? Fission reaction, clear reactor, yeah, to produce an electricity. But now people are seeking for creating fusion reactions. Yeah, fusion reaction is to combine two material becoming helium, like the process happening in the sun, and also people creating a fusion reactor. Fusion reactor is the cleanest technology in the world. Cleanest technology. Yeah. Why? Because it does not radiate gamma ray, does not radiate alpha ray or beta ray like fusion, like fission. Fission reactions, it radiate alpha ray, right? Gamma ray, and then beta ray. Each ray will be very dangerous for people. Yeah. So if there is, for example, Chernobyl, Chernobyl catastrophe. Yeah, in Chernobyl catastrophe, there are fission reactions, uncontrollable fission reactions. As a consequence, we have fission reactions unpredicted and emit to the environment. So the people get the consequence of its unpredicted fission reactions. They receive alpha, beta, and gamma, yeah, engaging cancer. But fusion reaction, it does not show or emit alpha ray or gamma ray or beta. So that's one of the cleanest. But the requirement, we have to provide almost 1 million degrees Celsius. Yeah, so that the fission could happen, like happening inside the sun. Inside the sun, the temperature of the sun is in 1 million degrees Celsius. Can you imagine how hot is it? 1 million degrees Celsius. Yeah. People could realize today. Yeah. So how by using laser. putting a laser into one point. So laser penetrate into what one material, hydrogen. So hydrogen in the high energy, yeah, creating fusion by itself, produce an energy. Good. So it received by a reactor and also release heat to the environment. So this is our technology, and afterward people mimic a technology like how the God create our universe. Yeah. So back to the nature, this is our future technology. So the future technology, it will come back into the nature. Yeah, back into the nature, because nature is so environmentally friendly, right? Yeah. So people must be aware their waste must be environmentally friendly. Yeah. So be aware when we dispose our material to environment, because sometimes it will get a bad effect to people afterward. Yeah. Okay, so but now also people will be aware why we have to use solar cell, because it's one of the cleanest technology in the world. Yeah, without emitting carbon dioxide, emitting nitrogen dioxide, sulfur dioxide. Yeah, like produced by fuel combustions. Okay. Here. Why hot object glow? This the questions could be.
Before, and maybe you've seen this scene in Predator where Arnold covers himself in mud to mask his body heat and the light it gives off. But why is Arnold's body normally glistening in the infrared?
Look at in the infrared, yeah, the people will see by like this. Yeah, it reflect to the temperature in our body, and also it reflect the activity of our biological molecular inside our body.
What causes this phenomenon? Whenever we discuss some phenomenon, we almost always wind up somewhere in the quantum world, because if you ask why enough times, eventually that's where you'll wind up. So it should come as no surprise that there's a bit of a quantum element to describe black body radiation. But luckily, we won't need to stick around here for too long. The first thing to tackle is to figure out what exactly is heat. I'm sure you've heard that heat is the kinetic energy of molecules or atoms within matter, and that's 80% of the story. But if we want to be a little more precise, we can say that heat is the excess energy that a molecule or atom contains above its ground state. This can be represented visually as changes in rotation, location, and vibration. These are all manifestations of excess energy. When we supply heat to something, we are simply forcing the molecules to undergo one of these changes. Friction is the interaction of the electrons between two surfaces repelling each other and thus moving them about. This movement creates momentum or changes in kinetic energy and subsequently heat. Now we have to enter the quantum world. The electron and the electromagnetic field have a very intimate relationship. Because the electromagnetic field is a manifestation of charges, and the electron has a charge, or its own magnetic field, changes in one directly influence the other. They're very much like a boat in water. The boat can't go anywhere without creating waves or ripples, and the more aggressive the boat moves, the larger the waves. Similarly, the boat can be influenced by waves as well. Therefore, whenever an electron changes its own magnetic field, be that by changing its momentum or wave function, it sends ripples or photons through the electromagnetic field. That is to say, a change in energy of an electron will always produce a photon. As we leave the quantum world, we keep this little factoid in mind. Changes in electron energy produce light. Blackbody radiation is ultimately the phenomenon we want to discuss today. And having learned that changes in electron energy levels produce light, we could hypothesize that maybe really hot objects glow because the electrons inside are changing their energy a lot. Let's see how that would work. If we visualize a simple model of an atom, we can see an electron whizzing about the nucleus. It exists in an orbital, and that orbital describes a wave function or energy state of our electron. As long as the electron is in that orbital, it has the same amount of energy. As one would imagine, it can certainly increase its energy by transferring into a new orbital, but not easily. An orbital describes a wave function, and waves are dictated by their boundaries. If we imagine a guitar string in a box and we wanted to change its wave function, we'd find unless the wave's nodes appear at the edges of the box, it will collapse. Therefore, only a handful of waves fit in this box. Our electron orbitals are the same, only certain wave functions will fit around the atom, and each orbital and subsequent wave function possess a unique energy level. So our bounded electron can only change its energy in quantized amounts, and these changes in energy stimulate the creation of photons or light. But how does heat play into this? An opera singer, singing at the right pitch, can cause a wine glass to break. Molecules naturally vibrate with thermal energy. Like the breaking glass, if a molecule vibrates with the right frequency, those vibrations can stimulate the excitation of an electron into a higher orbital. When this electron returns back to its ground state, it produces light. A vibrating molecule doesn't always vibrate with the right frequency to excite one of its electrons. But a vibrating molecule can vibrate against their neighbor and transfer some of their internal energy to them. This new excess of energy that was transferred can create faster vibrations, which in turn can then excite an electron. As we increase the temperature, more and more vibrations cause more and more excitation of electrons. Stronger vibrations also cause electrons to jump into even higher orbitals. Since electrons in higher orbitals possess even greater energy, when they return to their ground state, they emit even more energy. If we can excite an electron into a high enough orbital, at some point the light energy it gives off when it returns to its ground state will be in the visible spectrum. In matter, orbitals of nearby molecules and atoms overlap and create even more orbitals, or nooks and crannies electrons can occupy. So even though each orbital requires a specific amount of energy, there are so many of them that electrons can release a large variety of light as they transition around. So many that the light appears white to us if an object gets hot enough. That's the basic mechanism for most blackbody radiation in the visual spectrum, but there are a few more sources. Since the electromagnetic field is just that, a field, it has an orientation of where it wants things to be pointed, exactly like a magnet. In most places in the universe, the forces of the electromagnetic field are incredibly weak, but they exist. A lot of molecules are what we call polar. That means there exist charges at all times within its geometry. We'll visualize water for this. Water has very distinct positive and negatively charged poles. This means it's kind of like a magnet and has a magnetic field that looks like this. If the universe had its way, it would prefer for this field to align with its own. So there is a force that wants the water molecule to align a certain way. In order for the water molecule to rotate, it needs to act against that force. It needs external energy. So if we give it energy in the form of heat, it may rotate. And this rotation causes a change in the electromagnetic field, and thus a photon is created to mediate that change. But since these forces are so weak, the energy of the photon is very insignificant as well. Therefore, anytime a polar molecule even ever so slightly changes its orientation in space, it produces a photon. But these photons are extremely unimpressive, and as far as we're concerned, contribute very little to what we observe as blackbody radiation. The other main source of light in blackbody radiation is from free electrons. When things get incredibly and stupidly hot, like in plasma, electrons realize there's really no reason for them to be sticking around this hot mess and detach completely from their respective molecules. When an electron isn't bound to an atom or molecule, they're called free electrons. Free electrons can carry as much or as little energy as they want. When bound to an atom, they could only absorb specific quanta of energy. As a free electron, they can absorb whatever they want. Free electrons fly about bumping into each other and ions. These collisions greatly reduce their kinetic energy, or changes their influence on the electromagnetic field. This produces Bremsstrahlung, which is German for braking radiation. This isn't that common on Earth because most of our electrons have a home. But some of the light from lightning is due to this process. Lastly, we should be asking, why is it called black body radiation? This is simply a name assigned to a theoretical material that could absorb every single wavelength. In reality, all materials either reflect or let some wavelengths pass directly through them. And since we associate the color black with the absorption of visible light, we call a material that could theoretically absorb all light black as well. So when we measure the radiation from an object, some of it is reflected and transmitted. But black body radiation is the radiation that comes specifically from the object itself. Therefore, when we heat an object up, more and more of that observed radiation comes from the object itself. And that is black body radiation.
Okay, my question is, what factors influencing black body radiations? Arni? Are you there, Arni?
Yeah, yes, sir.
Yeah, would you open up your video? I can see your face.
Oh, wait, sir, because my outfit not good. Wait, sir.
Okay, Agnia from MIT, Arni from what year? University of Germany. Kiel, yeah, Prof. Ari, Kiel, University of Kiel. Okay, so which factor influencing radiations, Arni?
Actually, for this, I cannot get the material, sir. I just know about the
Have
first
you
one.
seen the video?
Yeah, I see, but in the
I
first
share?
one, but about the last, I don't understand.
Oh, you do not understand. But what you understand from a part point you have seen? Ayo, Arni. You are not concerned because you are not focused to the course. Okay, so another Atoila, yeah, okay, it's okay lah. Atoila is freezing. Yeah, right. There is no movement. Yeah, there. Yeah. Which factor influencing black body radiations? As you have viewed the video.
Maybe it's about the temperature.
Yeah, the mechanism of what black body radiation, as said by a scientist previously. Hello, Tia. Tia is not focused again. Okay, anybody please? Yeah, Diki, yeah. Okay,
may
Diki.
I try, sir?
Oh yeah,
Then
okay,
first.
Diki, and then supported by Rizky. Yeah, okay, Diki first.
Right.
Okay.
So,
Okay, Diki.
before I'm gonna answer, sir, the thing that you mean, how to increase the radiation of the black body, it's mean the increase of the light itself, right, sir? that
Mhm.
radiated from the black body, right? So as we can know from the video before that, the photon is gonna be resulted because the electron in having the excessive energy in the ground state. Therefore,
Yes, very good.
if I
Wow.
want to increase the photon intensity, it means I need to increase the temperature or the shaking of the electron itself. There's three ways.
Yeah.
It's shaking and then the repulsion, ding, 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 like that, sir. Like the
Yeah,
video
okay.
itself say.
Mhm.
And then when the energy is increasing in the electron, the shape of the orbital is going to be changed from the example,
Yeah,
the little one to the to the that one, and then to the bigger one, and then
orbital.
to the
Yeah,
bigger that one.
SPD. Yeah, orbital
Yeah, the
S.
SPD,
Yeah, reflecting P, and then D and F.
F,
Yeah, and so
yes.
on.
And
Because
then
we need here the particular level of energy so that the electron create an orbital. So it's not
yes,
all range of the energy electron create an orbital. Only a specific level of energy. So electron there are in the orbital. Like here, the Earth, it's only occupy in our orbit. Yeah, and also between Earth and Mars, there is no planet. Yeah, only a specific distance from the sun, a planet will occupy the orbit. Because, for example, if a Mars too close to the Earth, so the Mars will not create its own orbit. Yeah. The same case with the electron. Only a specific distance or orbital or level of energy, electron will form in a specific orbital. Yeah, Dicky said. When we change an orbital from one point to another point, it will emit the photon. Yeah, emit a photon or this the evidence. Okay, so Dicky next. Dicky, what you
right,
got?
sir. So it said that it needs the specific frequency that gonna change
Yeah.
the orbital itself.
Yeah.
But if the orbital is not changed, at least one atom is, if it's we gonna hit one atoms, it's gonna be going to another atoms, and another atom is gonna be ikutan vibrating together, and then that a lot of atoms vibrating together gonna be having higher vibration than one atom is gonna be vibrating itself. As the video sound, this one atom going to the another atom, and then every atom is gonna be vibrating, and somehow there will be some atoms they jump from the what's it called again? The nucleus, and then it's gonna be transferred to the another one, and it's called free electron from the sun. That's why the electron there is free electron from the sun, because the protons.
Sun and also plasma.
Yes.
Plasma and thunderstorm. Thunderstorm,
Yeah, thunderstorm.
plasma. Yeah, that's the evidence also happen.
Example, yes.
Mm.
And so the conclusion of that, how to increase the energy from the black body radiation, is for the increase in for example, for the temperature itself. Of course, it's temperature because the temperature is gonna be vibrating the electron itself. That's one way of making it how to increase the energy level. So that's the answer,
Yeah.
sir.
Oh, I lost Mufti. Where is Mufti? Mufti is left from the Zoom. Okay, Rizky, support an idea. Yeah, unexplained by Dicky. Okay.
In my opinion, black body radiation is like more or less what is it called? So when the temperature is reach 0 Kelvin, so that's mean that object is perfect black body, isn't it? And when we increase the radiation from black body object, so we can increase the energy. For example, when the black hole menyerap cahaya,
receive light.
Light, so
absorb a light from light.
Absorb a light, so the light have large energy, right? So inside the black body object, so the electron can, what is it, vibrate, isn't it? So
Excited or vibrate, yeah, electronic vibrations.
yes, so that can affect the, what is it, energy transfer. So I think by increasing the light or the energy, we can increase the black body radiation also. I think that's my opinion.
Yeah. So I imagine by the key Rizky explanation, if we decrease the temperature of an object become 0 Kelvin, all object becoming black, yeah. All object becoming black. Although this object is white, but if we decrease the temperature becoming 0 Kelvin, yeah, negative 273, so all object becoming black because there is no electronic excitations. And also the chemical structures, yeah, becoming ruptures. Yeah. Okay. I have here, please open the link. Yeah. I have a simulation of PET, this one. Open this link and please fill the worksheet I provided. This link, okay. And I provide a worksheet for this experiment. You can try it by yourself based on the guideline from the worksheet. Okay, so, and please report your activity. You can consult me within this time. Once you have questions, please don't hesitate to ask me the questions. Okay. I share it through here first, yeah. Afterward, I will upload it. Okay. Can you open the simulations?
Still loading, sir.
Okay, just wait. Okay. This is I share it through chat. Yeah. I will prepare. Firstly, from absence. Yeah. In SPADA. Spot. Yeah. Spot. Rizky. I don't know how to check the absent in spot yet. So please check together. So we still have a time. So open the file and then look the instructions and then perform the experiment. Yeah. Here. Similarly, I have to share an idea to you, but you can try to perform the experiment in detail. Look at, you can consider here applying a potential difference. Yeah, this is applying potential difference in order to stop the electron excitations. And then, firstly, you can try it by improving the potential difference little by little. Yeah, it can be set by yourself. For example, 1.6 by yourself, like this. You can set your own potential difference by yourself. Depend on your investigations, and afterward look a data from the graph provided: current, voltage, stopping potential, current versus light intensity, and then here energy, yeah, versus light frequency. This is also the frequency. Yeah, we can set here. You can set your own data. Okay, and also the intensity can be increased or decreased by yourself. Yeah. Okay. And also, what's the phenomenon of here? Photon here. I gave a potential difference or set to 0 at first. 0. Yeah. And also see a current. And then here the intensity. And you can also change the material, for example, sodium. This sodium. And look the current, yeah, 0.07 milliampere, for example. Yeah, this is 0.07 milliampere. Okay. And afterward, we can increase the potential difference. What happened if we increase the potential difference, wait a while, and look a current change, and then you can also increase the intensity. What happened if we increase the intensity? Look at the current change, right? And also we change the frequency. Here, for example, this is just a frequency, and we increase its intensity. Will it affect to the current or not? Yeah. Or we stay in the same frequency, but we change a potential different. What is the stopping potential? Yeah, look here. Yeah, so please report in lab. Yeah. Okay, in our lab activity, yeah, virtual lab activity. But you can do the same thing in the real lab by using solar cell. But this is from the first experience. Report from this lab activity: experiment in physics, laboratory photoelectric effect, yeah, PET simulations. You can try, look the experiment. Is it the group work? No, this is your individual work. Yeah, so please do it by yourself to gain your real experience. Yeah. And afterward, we can do it the same thing in the lab afterward. After we have an equipment and you have an access to go to the campus. Okay, any questions?
Sir, excuse me.
Mhm.
The PDF one, I can open it. I don't know
You,
why.
you can open it?
Yes. It's just like this, sir. Let me share my screen.
Oh yeah. Oh yeah, I have to allow first.
Like this, sir.
File not found.
Yes.
Seriously, the other please. Agnia, can you open the file?
Yes, sir, I can open the file.
Maybe you can. I can share it through WA ya. Okay. Okay. WhatsApp. Yeah. Okay. You can try to do by yourself. I will check spot while you are working with virtual experiment. Yeah. Okay. Let's try. Nah, this is the video to make you remember the previous real experience through photoelectric effect. Yeah, that's the YouTube link you can access. If you need to do it privately, you can go to your own breakout room. Maybe if you need, it's up to you. Yeah, it's up to you. Maybe, for example, Mufti want to discuss with Rizky. It's up to you. You can go inside the breakout room. But actually, data must be discussed individually, yeah, to gain your real experience. And also, can you here take an attendance in SPADA? Maybe, sorry, I check SPADA first. Oh, here, there's SPADA. You can also put attendance in SPADA. Oh yeah, Mufti, yeah. So I record Mufti ya by me ya. Okay, it's complete. Everybody come to the class and check spot. Repot banget nih. We have to chat the spot by UPI.
Sir,
Yeah.
can I ask something, sir?
Okay, Diki, please.
It's about the video that I really want to add something. The video before. So every material or every atom has its own polar. For example, let's say H2O or water. It has its own polar, so it's gonna be going from the south to the north, or from the north of the hydrogen bonds with the oxygen to the oxygen itself. And it's said before, the Earth has its own magnetic field, but the polar is so low, so its need we can change the magnetic field in beside our surrounding. For example, the H2O before, the H2O, if it's not in the same way as the magnetic field of the Earth, is gonna be making itself to be aligned with the magnetic field of the Earth. But it said if we exert some force, the magnetic force surround the water itself is gonna be changing with the water. Is it right? Right, sir?
Yeah.
So
It is right.
I have the question is, if I'm gonna boil a water and then I wanna to try to put the magnetic needle like in the compass, and then I'm gonna put the agabus in the hot water, is the magnetic needle gonna be pointing the north or not? That's the question, sir.
Yeah, you can try it. Yeah, the magnetic field will point to the north. Of course.
It's still, sir.
Yeah, it's still.
Right.
You can try the key. You can try by yourself. And also, why we cannot make a magnet from water? Because water phase is in liquid. You can make a magnet of water by freezing water first. Please freeze the water, and afterward reorient. During freezing a water, reorient a water so that its molecular polarity sent to one direction. Afterward, the ice of water will behave as magnet afterward.
But
the evidence you can see also when the water influenced by electricity. Yeah, we rub the plastic into our head, and afterward there is water. Yeah, and also we approach into the flow of the water, free fall water, and then approach the electrified comb, for example, and water flow influenced by electricity. Yeah, static electricity. This is the evidence that the water is polar.
All right, sir. So I do have a question after sir saying freeze the water first, right? So the electron inside the atom can be changed. If we hit an atom, the electron is gonna be going wild and it's gonna produce energy. But what if we are gonna freeze it? Is it gonna be exert some energy by the atom itself?
Yeah, of course. If it freeze, it means that it release an energy. Yeah, from the system. Yeah, when we freeze on the material, means it release an energy. If the material temperature increase, it means that it need energy to absorb. When it absorb energy, the material absorb energy from environment. The temperature of the material will increase, means it absorbs the energy. Yeah, absorbing energy thermodynamically, it will increase the temperatures of the material. When it releases an energy from the material, yeah, thermodynamically, it will decrease its temperatures of the material. This is the consequence of thermodynamic. Yeah, thermodynamic depend on not only temperatures but also pressure. If we increase the pressure, also it will receive more energy. Yeah. If we decrease pressure, it will decrease also an energy, internal energy of the material. Because of a tendency of material collide to each other in a room. When we have a greater tendency of material collide each other in a room, yeah, as the consequence, the internal energy of material will increase. This is what Stefan Boltzmann say. Yeah, E equal to half KT. KT, the internal energy of the material. Okay, so temperatures reflecting to internal energy. Yeah. We have also enthalpy. Remember enthalpy, and then Gibbs energy. and then internal energy, and what else in chemistry, physical chemistry? Have you ever learned before? Spontaneous chemical reactions, non-spontaneous internal reactions, and then what exotherm, endotherm chemical reactions. Yeah, so this also relate to physics, physics and chemistry, physical chemistry.
All right, sir. Thank you for the answer, sir. Now I'm becoming more pusing, sir. Tapi semoga mengerti nanti, Mas, sir.
No, that's a way to you to what become in the science in your heart. So we do not separate. Oh, this is mechanic. This is physical chemistry. This is what else? Thermodynamic. Oh, it's about the science. Yeah. Yeah, we are scientists. Yeah, so science, it must be in your heart. If you immerse a science into your heart, your feeling will be like a scientist, inshallah. Yeah. The most important thing for a science teacher is your scientific understanding. Although you have best approach to teach a science in many way, in many methods, but if your conceptual understanding is low, you explain the wrong scientific concept. Wow. It should be better you do not understand the way to teach, but you understand the science in deep. Rather than you can explain a teacher interactively of science, but you conduct a wrong concept of science. Yeah. We respect to the people, although they cannot explain a science while they are a teacher to explain the material well, but their conceptual understanding is strong. Rather than you could explain everything, but you explain the wrong scientific understanding. Yeah, because we have to explain what everything based on the scientific inventions. It's my principle. Yeah, it will be different if you ask another pedagogical teacher or lecturer. No, they will say it not. They will be aware with TPEC and etc. But we concern on scientific understanding. Yeah, because it is the heart of the science. The heart of the science is everything you explain it scientifically correct. Once you have a question, you can ask the questions. Yeah. I provide many slides, but I think that not all of the slide must be directly discussed to you as you catch the material. Yeah. But I will share. I will share all the material in Spada. Oh, here I have to insert here Spada spot ya. You have to check the spot first. Bismillah, kita coba ya. My question, Rizky, in order to feel the present in spot, does it must it be feel on the time of the course, or we can feel since beginning? This is my question, Rizky or Agnia.
I think for each meeting, sir, in
each meeting,
in that time when
the time of the meeting.
Yes.
Okay. I will put I put the content first. Yeah. So please try to here add the presence in this modern physics class. I give a protest to UPI. Yeah, why UPI only accept spot for attendance? Yeah, I don't know the reason. Because to me it will be easy to prepare the BTA in Spada, not in spot. It must be put it bot. Sabar aja lah ya. Okay. Which meeting today? Meeting 3, meeting 4. Oh, now it's meeting 5. Alhamdulillah. It's meeting 5. Okay, ya. Meeting 5. 1, 2, 3, 4, 5. Yeah. Do I have holiday in September?
No, sir.
Oh yeah, no sir. Yeah, so we start at 9 September first. So now meeting 5 in 7 October, right? 9. Okay. Rizky, please open here, spot modern physics and everybody. And take an attendance in spot. I have to check the response afterward. Oh, we have to set KM ya. Who will be KM? Mufti or Rizky or Diki?
Boleh, Kang Ujang aja, Kang Mufti aja, Sir.
Oh, Mufti. Okay. Mufti ya. Set KM, try. Okay. What next? Afterward, click attendance for you.
In Spada or Spot, sir?
Spada, you have taken attendance, right?
Yes.
Afterward, open spot also. So we have to set attendance both Spada and spot. Spada is from me to a real recap, but spot it is a must from UPI for this semester decisions. UPI must record all attendance through spot. Jadi nyapein saya, nyapein kalian juga.
But I'm sorry, sir. In Spot, it doesn't has attendance in meeting 1 and also for meeting 5 today.
Now it's meeting 5, right? So
Yes.
how do you take an attendance in Spot?
I think the lecturer need to do it instead of the students, sir. So I think it's only the lecturer that can record our attendance, and then the person the KM will accept it. Sir.
The question I don't understand.
Yeah,
help me, please. Here, I share. Here, yeah.
Okay.
This is modern physics, yeah, in Spot. And afterward, what we have to do next? Setting RPS.
Mungkin rekap kehadiran.
Here, setting RPS, I have set RPS, right? The problem is how can I recap the attendance for you? Here, daftar mahasiswa, daftar nilai, rekap kehadiran.
Rekap kehadiran seperti.
Rekap kehadiran. What next? Here, nothing for me can be done. Look at, I cannot set your attendance.
You can try in every meeting in the monitoring, sir.
Here, and afterward monitoring.
Yes.
And what next?
Here. Yes.
From Risalah.
Yeah. This is it.
Oh,
and Kang Mufti will accept it.
Okay. So here, afterward, this one and simpan.
Yeah. Yes, sir.
Oh, okay.
And Kang Mufti will assess it.
Mufti, please here accept to all attendance from meeting 1 until meeting 5, right? Oh, here.
Yeah.
Syllabus. Okay. I see. So, have you ever here? Oh, Aziza, do not enter right to the class.
Yes, Aziza and Salsabila convert from kampus mengajar sih.
Oh, but it's only conversions. But if I said not hadir, maybe in the end there will be a problem for their mark, right?
Yes.
Ya udahlah, saya okekan aja lah gini ya. Okay. Have you ever absent through the class within 5 meeting in this course?
No, sir.
No, all of us always come to every meeting.
All of you, yeah. Okay. I only try to put all attendance in Spada to make sure there is no problem with the registrations in the end to UPI. Yeah. Maybe because this file will be integrated to the score in UPI. So if I do not set attendance in Spot, maybe there will be problem to you and also problem to me. Me is assigned we are not attending the class, and you also will be set not fulfill 80% of the class enter. This will be a problem. So we have to put all attendance in SPADA in spot 2. Okay, and then meeting 4. Okay, I see now here. That's the way. Okay, I'm sorry to make you mind. It's me mind too. Anyway, and now Mufti, please open spot and accept all attendance.
I'm sorry, sir. Mumpung lagi di spot gitu ya. Buat teaching preparation sama electricity and magnetism juga belum ada, sir.
Yeah. I will set the same thing with you, Rizky, right?
Yes,
so I will
but
set
teaching
today.
preparation with Abi. Teaching preparation with Abi.
Oh, with Abi ya.
Yes.
Okay, so I will contact Abi. But I will through Rizky lah ya, Rizky.
Yes.
Remind Abi ya to set. I will reflect to the attendance from SPADA, checklist, and afterward I need Rizky to also remind Abi ya, Abi. I will contact, but Abi sometimes it's not easy to reach. That's from me. Rizky will fast respond like Mufti or Diki, but maybe Abi it's not easy to directly respond our text. And also Mufti, could you check please?
I think Mufti connection is bad, sir. Mufti connection.
Oh. Maybe to make it easy, Rizky, I only ask you, are you okay to be all KM ya? Yeah, it's only
for me,
Rizky to make me easy.
Boleh aja, sir.
Nah,
tapi
gitu aja.
Nanti saya bilang ke Abinya ya.
So I set Rizky for all attendance, so me easy to contact you, and also for all purpose. Itu aja lah biar gampang.
Yes,
Kita ambil gampangnya aja.
Yes, sir. Thank you, sir.
Okay.
Sir.
And yeah.
About the attendance in spot, I already accepted all, sir.
Oh ya udah tuh. Thank you kalau gitu ya. Okay, thank you Mufti ya. Okay, Mufti for modern physics and Rizky to teaching preparations and what else? Electricity and magnetism ya. So I will put right now maybe should be better to track all the material. Okay. Let me see the attendance. Okay. Thank you, Mufti. Because why we need spot? Because in the end we need here BAP ya. BAP cetak ya. Oh here. Mufti here meeting 1 you still not approve. Still check here uncheck list. Mufti please recheck meeting 1. Introductions, description and syllabus. Hello?
Yes, sir, it's already.
Oh ya, sip. Alhamdulillah. Any question regarding the experimental activity you do? If there is no any problem, maybe you can continue at home and then afterward submit your assignment through SPADA. Yeah, I will set the assignment through SPADA. And see you next week. Next week we will study about UV spectroscopy. Yeah, UV spectroscopy. So we apply radiation activity for chemical identification and electronic excitation. Wow, interesting. Yeah. So UV-Vis will be one of the powerful equipment in order to identify the electronic compound. Wow. So now we will combine chemical physics and physical chemistry into one course. Major in physics. Thank you for your attendance. In case you have a problem, just let me know. So I will be happy to help you, inshallah. Okay, thank you for your attendance today. I would like to say regard to your family, stay safe and healthy. Inshallah, you will be happy in the end of the day. We can get a real meeting. Real meeting. Entering the laboratory, inshallah. I will say alhamdulillah, alhamdulillah, alamin, and praying to Allah subhanaka wa bihamdika, asyhadu an la ilaha illa anta, astaghfiruka wa atubu ilaik. Bila taufiq wa hidayah, wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Thank you very much.